In this lecture, we shall be talking about something called steganography. Okay? So, the title of the lecture is steganography. Now, let us first try to understand what we are trying to discuss here. Now, we talked about networks, we talked about some security issues and security protocols that are typically used over a network to secure our data, to achieve confidentiality, authenticity, integrity and various others. Now, here we are talking about our own data, our own communication, we are trying to secure them. But to imagine, we are now living in a world where so many different kinds of communication are going on over the network, over the public network. Well, we are securing our own network all right, but there are some other people which may not be that innocent, may not be that good, who are also communicating among themselves with some malicious intent. So, we should be on the alert, we should also be try to find out whatever is going on, what the others are sending and receiving over the network. This is just from the point of view of securing our, you can say, infrastructure and in a much larger context securing our nation. Okay. So, if you can detect some communication that is going on, then you can take some action, all right. But steganography is a technique which is meant to hide some information so that you cannot detect them so easily. Let us look at it. Now, in this lecture we shall first be talking about steganography and digital watermarking, what these are. These two are very similar things, but maybe they are used in slightly different context. And steganography can be used in many different kinds of files. We shall specifically be looking at some examples with image files, and we will look at some examples. Okay. First, let us look at what steganography means. Steganography, as per the definition, if you look at the dictionary meaning, it means covered writing. It has come from a Greek word. Covered writing means you have written something, but you are hiding it, no one else is able to see it. This is the basic idea. Hiding messages in innocent media. Innocent media means generally you will not have any idea at all that there is some hidden message that is being carried, but somehow that hidden message is hiding inside an apparently innocent media. It can be a very nice picture, you are viewing a very nice picture, but inside that picture somewhere some information is being hidden. Okay. This is steganography. Okay. Steganography may or may not be used in conjunction with cryptography. So, if the person who is hiding the message is doubly, you can say, aware of the fact that he also wants to do some encryption before hiding, so that if someone at all breaks it, if someone finds out that there is steganography and extracts the information, but still because there is encryption, that person will not be able to decode it. So, you may possibly encrypt the message before hiding, that is a more sophisticated way of data hiding. Okay. Now, the thing is that in a normal channel, if you send an encrypted message and if I capture it, then if I am not able to read it, that means it must be encrypted. So, the first thing is that there will be some suspicion, that means what are they sending among each other that they have to encrypt? Are they good people or they are not so good people? So, I do not know. Okay. So, any message flowing through in an encrypted form may raise suspicion. Okay. So, the other alternative is to send in such a way that no one will suspect at all, the message will be hidden, there will be nothing visible which can attract any suspicion. Okay. This is the idea. Digital watermarking, as I said, is something which is very similar to steganography. Here also we are hiding something, but here there is a particular application why we are hiding. Here let us say we can have some copyright information, like for example, some company produces some music, let us say some music CDs, some movies on some media, CD, DVDs, Blu-rays and whatever, various medias are there, online media. Now, there can be some copyright or ownership information, there can be licenses and other information that may be hidden into that media, which the person who is downloading and listening will not be able to see. But if a person makes unauthorized copies, then the law enforcement agencies can check that and try to find out who was the original owner and whether it is a legitimate copy or not. Okay. This is different from steganography only with the intent. Normally, we use the term steganography with the intent that something wrong is trying to happen. Someone is trying to send something without the others knowing, that means they do not want to share it with others. Maybe some very secret information or very, you can say, not so good, something malicious is going on. But in digital watermarking, we are trying to protect the copyright of some information which are generated by some authorized parties. Okay. But the technologies are similar. Okay, let us look at the history of steganography and look at some of the very classical examples. Well, the very first example of steganography was very interesting. So, what happened? Some very secret information needed to be sent from one place to another, long distance. So, what was done? A messenger who was carrying the message, so he was not carrying the message on a piece of paper. So, if the messenger gets captured, then the paper will also be seen. So, what was done? The head of the messenger was shaved and some tattoo or some information with permanent ink was marked on the head. Then some days were given so that the hair can again grow, and then the messenger was sent. So, apparently even if the messenger is caught, no one will suspect that he is carrying some secret information on his head. So, when he reaches the intended destination, his head will be shaved again and the hidden message can be read out. So, this was actually used in ancient times. Okay. And during World War II, some very simple type of this kind of steganography was used for some German spy to send a message from one post to another. So, the idea was very simple. He was carrying a printed message on a piece of paper, but the content of the message was apparently very, you can say, straightforward, nothing suspicious. Let us say apparently neutral's protest is thoroughly discounted and ignored, Isman heard it, blocked it. Well, you cannot make anything out of it, but the sender and receiver knows how the information was hidden. If we extract the second letter of each word, like I extract this P, E, R, S, H, I, N, G and so on, then you extract something like this. Pershing is maybe the name of a ship, it sails from New York June 1. So, this is an information which you are sending to someone else, so that that person may be able to attack or do something based on that. Okay. So, this was one of the very old form of steganography. Okay, we use some terminologies in connection with steganography. We talk about a cover medium, that where we are hiding. If it is a text, that is our cover medium. If it is an image, that is our cover medium. If it is an audio clip or a music file, that is our cover medium. So, where we are hiding? Okay. Then the embedded message, and if you are using encryption in addition some kind of, then there has to be some key also, let us call it steganographic key or stego key, and all three combined together will generate the stego medium. Now, the objective is this cover medium and stego medium should look very similar. A person who does not know that this is carrying some hidden message will not be able to distinguish just by looking at the stego medium. That person will feel that he is actually looking at the original file only. Multimedia files are typically used to hide messages like images, sound, movies, binary files, text files. But there are other ways also, like you have seen the IP packets, network packets. There are some fields which are unused. Those unused bits can also be used to carry some message or information. So, there are many ways, there are many fields in data, in files which are not used. You can also use those fields to carry some data, like some executable files. You compile a program in C or C++ or Fortran, whatever, you generate machine code. Now, in the machine code, in the header there are lot of fields which are not used. You can also use those fields to carry some hidden information. Okay. Now, specifically as I had said, we shall be talking about steganography in image files. Now, a few terminologies. The size of an image, we talk about an image in terms of picture elements or pixels, how many dots are there. We imagine that a picture is made out of dots. Let us say we say 1024 by 1024. There are 1024 dots horizontally and 1024 dots vertically. Okay. That will define the size of my image, and each picture element or pixel will be having a color. That is how an image is formed, and a color is typically specified by some combination of the fundamental colors red, green, blue. You know, these three are fundamental colors RGB as combination of red, green and blue. Typically, each of these red, green and blue can be represented in 8 bits or a byte. In 8 bits, the value can between 0 and 255. Now, in hexadecimal, it will be 0 to FF. Let us say black, the color black, where red, green, blue, all these components will be 0. So, it can be encoded as 00, 00, 00, red, green, blue. Let us say white, white means red, green, blue all are at their maximum intensity. So, it will be FF, 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 that is white. If you talk about pure red, only the red component is FF, green and blue are 0. Okay. If you talk of yellow, red and green combined makes yellow, blue is 0. So, in this way you can generate any possible colors, right. Now, it depends on what kind of image format you use. For example, in the GIF format, which is very popular, here each pixel is typically represented by an 8 bit value. But in JPEG or BMP formats, we use 24 bit value for each pixel. Okay. And this image data, well, there are image formats which are uncompressed, but normally they are in compressed. GIF, JPEG, these are all compressed form, they are stored. Now, when you are doing compression, there are two terminologies, lossless compression, lossy compression. Lossless means you are compressing all right, but if required you can uncompress it and get back the original image. There is no loss of information anywhere. So, the exact pixel values can be generated somehow. But in lossy compression, JPEG is an example of lossy compression, where you are trying to reduce the size of your image file and you cannot get back the original. You are reducing the quality of your image in some sense. So, only approximate pixel values are stored. Okay. So, you should understand these distinctions. Now, as I had said, in a GIF image format, which is graphic interchange format, where each color is encoded in 8 bits. Now, in 8 bits you can represent 256 colors. Now, you may say that 256 colors is not sufficient. There is a concept of a color map table. In GIF, you can change from one color map table to another. Each color map table will support 256 colors. Okay. So, in the color map table, this 8 bit value which is stored, it will refer to one of the entries in the color map table. From there you can extract a color from the color map table, and that color can be encoded in 24 bits also. Okay. JPEG, as I said, JPEG uses 24 bit color format and that uses lossy compression, because internally it uses discrete cosine transform to make some transformations, compression, and then it generates the final JPEG file. And during that you can also adjust the quality of the final image. Okay. And they use the compression algorithm LZ, Lempel-Ziv compression algorithm. Okay. These are not very important to remember. Now, talking about steganography, which you are more interested in here, one of the very simple methods using which you can hide information in an image file, not necessarily image, in any media file in fact, is called least significant bit insertion or modification. The idea is as follows. You see, in GIF image format, I said you use 8 bits to store a color. In JPEG, we use 24 bits, red, green, RGB, red, green, blue, 8 bits, 8 bits, 8 bits. Then LSB it says, let us say in JPEG, it says you can modify the least significant bit of these colors. You see, the color can be from 0 to 255, right, each of the components RGB. So, if you change the LSB, that means I am either increasing it by 1 or decreasing it by 1. There will be a very small difference in the color in the actual image. You will not be able to distinguish if you see it with your eye. So, what if I put in some secret information in these places? Suppose I have a message I want to send, it requires 1000 bits. So, I use 1000 of these pixel bytes. I put this 1000 bits in the least significant bit positions. Someone, when he or she views the image, you will not find any difference, the image looks exactly the same, but in the LSB positions some other information is hidden. Well, you can use either one LSB or two LSBs if you want, there will be a little bit degradation in quality of the image, but you can hide like this, right. Now, property is that this is very simple to implement. Lossless compression, this is most suitable, because if you do a compression, lossy compression, then the LSB's positions might get lost. You cannot use LSB steganography with JPEG images, for example, right. JPEG is a lossy compression. 24 bit images, it is easier because you have means 1 bit you take up for each of the colors, it will be very small changes in the final color value. Grayscale images, where you are not talking of colors, but black and white and shades of black, gray, these images work. And as I told you, these are vulnerable to image manipulations. When you transform an image, when you do compression, decompression, lossy compression, these LSBs will all get lost. So, this hidden method might get easily lost if you do some kind of media manipulation. Well, there are some other methods also, masking and filtering, like you can mark the image in a way so that it is very difficult to detect, like you do not modify all the pixel in the image, rather only certain locations in the image you modify the image, you change the intensity a little bit. Usually the busy areas of an image, see there may be some part which is the same color, like the sky is totally blue, do not modify that part, because even a small modification can be easily visible. But there is a house, there is a man, there is a flower, lot of things are there. If you make some small changes there, it will not be easily visible. So, here we talk about that. Now, there are methods which are more sophisticated, where you use some algorithms and transformations before you can hide. So, you do not directly hide the data in the image or in the sound file or in the video file in the LSB directly, but you carry out some kind of a transformation, like discrete cosine transformation is one popular method, using which you can hide a message in a JPEG file, but not directly in a JPEG file, you have to use DCT. Then there can be discrete wavelet transform, DWT is a very popular method that is used in the context of steganography. You can use it to hide information in different types of media, right. So, these algorithms and transformations are more sophisticated techniques, where even in lossy compression methods you can store some information, hide some information, and there will be some degree of robustness against transformation. Like earlier I told you, LSB transformation or means LSB steganography, the data can be easily destroyed, but here even if you do compression and decompression, the data may not be easily destroyable. Okay? These are more robust. Let us take a very small example of LSB steganography. Let us say we want to hide a single letter C, just one letter, we take an example in a GIF image, and C in terms of ASCII code in decimal is 67, in binary it is this 0100 0011, 43 in hex, 67 in decimal, etc. All right. So, let us suppose the GIF image will be a large image, here we have to hide 8 bits. So, let us look at 8 bytes in the GIF image. The first 8 bytes, let us suppose, are like this. What do? We modify the least significant bits to hide the 01000011. The bits are marked in red here, you see 0, 1, 0, 0, 0, 0, 1, 1. This is how we are modifying the LSB to hide this letter C. So, in this way you can hide the other letters to store the entire message you want to carry in the image. Okay? Fine. Okay. Let us take some examples here now. Will you see, this is one image you can see, this is a picture which is the cover image, and inside that cover image this entire text is hidden, and a modified image is also generated. You see, of course, you can generate the whole image also, but here only a part of this is generated, no, there is no problem. You see, apparently you do not see much difference, well, maybe the quality has been degraded a little bit, but unless you also have the original image with you side by side, you cannot really know that whether there was any degradation or not. But if someone gives you this picture, you can say, well, this is a fine picture, okay, I can recognize this person. But this image is, this is the stego image, this is hiding some information inside it. You will not be able to detect that easily. This is another example which is which was publicized, it is available in the public domain. Here this is a famous piece of art, this was considered as a cover image. Inside this picture some other picture was hidden. This was the map of a strategic Soviet bomber base. This was a satellite picture which was hidden in it, because any picture means what? Ultimately a stream of zeros and ones, that was hidden inside this larger image. And after hiding, you see the Stego image look like this. Well, you do not see much difference, you can still identify that picture. Maybe you will feel that, well, this picture was not of that good quality, maybe a little degraded, but fine. The same image, you can identify the image, but you will not understand that such a critical information is hidden inside this image. Okay? These are some examples. Now, another example I am showing, let us say this is a picture of a baboon, the face, and this is the picture of a person you are hiding inside this, and this is the final image. Just by looking at this picture, you will not be able to understand anything that such a big image is being hidden here inside. So, this is what steganography is. It is rather easy to hide an image, but suppose you are a person who is on the lookout of whether such secret message is being transmitted by some parties which are suspect, whom you feel they may be exchanging some information which are detrimental to your security, then you should be able to identify or try to identify whether such things are going on. This is a field of research called steg analysis, steganographic analysis, but it is very difficult. If the person who is hiding an information is very intelligent, it will be quite difficult for anyone to understand whether some hidden information is being carried with a media file. Okay. So, with this we come to the end of this lecture. In the next lecture, we shall be looking at some other means of security which is also used quite popularly nowadays. Thank you.